Jai Hind. So today this is our fourth lecture for the subject data warehousing and data mining. In our previous lectures, we have already talked about that what basically warehousing means, how we can store information in a secure way so that we can use it in future for any other reference for predicting something. In the same way, we have already talked about the data mining term, in which we are going to extract the important information according to our requirement out of a bulk of information pool. So with this, the next important topic which we are going to discuss today is binning. What basically binning means, it is something which helps us to reduce the noise or error out of any information or data. So if we will talk about the actual definition of binning, it says that data binning, also called the discrete binning or bucketing, is a data pre-processing technique used to reduce the effects of minor observation errors. It is a form of quantization. The original data values are divided into small intervals known as bins, and then they are replaced by a general value calculated for that bin. This has a smoothing effect on the input data and may also reduce the chances of overfitting in the case of small data sets. So as written here, binning something is we are going to pre-process the data in the form of small bins or bucket. Bins or buckets. Small things are there in which we are going to keep our information. We are going to divide the information in form of bins or buckets. Just the main purpose is to remove the error or noise available in it. How we are going to do it? There are certain steps for it. Step number 1 is sorting. Sorting means we are going to sort the given information or data in ascending order most of the times. For example, if we are having a series, something like this. This is just an example. First of all, the main thing, the very first step is we need to sort this. For sorting, it will be 1, 1, 2, then 6, 7, 7, 9, 14, 21, 22 and 27. It is like this. After sorting, the next step says divide into bins. We are going to divide the given values in the bins or buckets, you can say. Here total number of values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how I am going to divide it? Let's take one more number, that is 28. So the best possible way to divide it is 3, 3, 3 and 3. We have divided it in such a way that we have total 4 bins or buckets, or another way is make a pair of 4 like this. So now we have total 3 bins, each consists of 4 values. Next step says that we are going to perform the smoothing. It may be in these 3 ways: smoothing by bin mean, bin median and bin boundaries. In these three ways we can perform binning. What this mean says that whatever number of values you have, just find out the mean for it. If the number of values, for example, here we have 1, 2, 6, 7. 1 plus 2 plus 6 plus 7. Total number of terms are 4. Divided by 4, it will give you mean. So whatever value you have over here, it will be used for smoothing purpose over here. Next, bin median says we need to find out the median for it. If I am considering this particular bin, it has 4 terms. Obviously, if the number of terms even, then it is n by 2. and if it is odd, then for that it is n plus 1 by 2. Bin boundaries. Bin boundaries says in this particular thing, the value is near or closer to which particular boundary, to the left side or to the right side. Whichever is closer, we will replace it by that. For example, it's 2. 2 is closer to 1 or it is closer to 7. Obviously, 2 is closer to 1. It means 1, 1. Now, 6 is closer to 1 or 7. It is closer to 7. It will be replaced by 7. So, this is the new value after bin boundaries. So, like this, these are the certain steps by which we are going to perform this binning. Let's have a proper example for it. Let's do it with the help of a question, the example, by which it will be much more clear to you. Here we are having certain items 1, 2, 3, 4, 5, 6, 7, 8 and 9. Total 9 are there. First of all, the very first step says that you need to perform sorting. After sorting, it will become 2, 10, 18, 19, 20. It's 18 twice, then 19, 20, 22, 25, 28. Here we have these sorted values. Now we need to divide it into bins. I am going to divide it on the basis of 3 items in each and every bin. So like this, you can see that we have 3 bins or buckets with us. Next step says that we need to divide, after division, we need to perform the removal of noise, which we can perform by the smoothing. And that smoothing is going to be done with the very first step, that is by mean method. If we will take mean of it, it will be 2 plus 10 plus 18 divided by 3. 30 by 3, that will be 10. Next says 18, 19, 20, that is 18 plus 19 plus 20 divided by 3, and it will give you 10, 20, 30, 40, 50, 57 by 3, that is 1 and 19. For the last bin, 22, 25, 28, it will be 22 plus 25 plus 28 divided by 3. 75 by 5. That will be. It is like this. Oh, it is 3. It is 25. All right. So like this, what we have these 3 mean values. Now, this particular one is replaced by 10, 10, 10. This particular will be replaced by 19, 19 and 19. And this particular will be replaced by 25, 25 and 25. Like this. So this is what smoothing by bin mean. Now let us talk about the next type, that is smoothing by bin median. What the median says? That if the number of terms are even, then it is n by 2, and if the number of terms is odd, then it is n plus 1 by 2. So here the number of terms are 3, that is odd. For odd number of values, we are going to perform n plus 1 by 2. 3 plus 1 by 2. That is 4 by 2 equals to 2. That is second term. So second term will be 10, 19 and 25. So according to smoothing bin by median, we have 10, 10, 10. This is the first bin. Second one is 19, 19, 19. And third one is 25, 25, 25. So by this we can say that in this particular question, when we are performing the smoothing using mean and median, the values of bins are exactly same. Let's come to the next one. Third part is bin boundaries. For bin boundaries, what we are going to do, the number of values we have are, these are our initial bins on which we need to perform smoothing by bin boundaries. It is like this. So out of this, 10 is closer to 2 or 10 is closer to 18. It is exactly the same. The difference is exactly the same number of values. So you can replace it by any one. I am going to replace it by 2. In the same way, 19 is closer to 18 or 20. Same thing. So I am going to replace it by 18. Here, it is closer to 22 or 28. Here also the same values. That is, I am going to replace it by 22. So this is the smoothing of bin by boundaries. So like this, we have solved this question. As you can see, it is by median. This is by mean. This is by median. And this one is by boundaries. Now let us take one more question to make this particular thing somehow more understandable. Suppose a group of 12 sales price records have been stored as follows. Here it is. Now again, by using the bin values, we need to perform the bin technique. We need to smoothen it. We need to remove the noise or whatever the error is there. We need to minimize it. We need to remove it. So let us say first step will be sorting. In the sorting, we have 5, 10, 11, 13, 15, 35, 55, 72, 92, 204 and 215. Like this. Twelve values are there. Five, 10, 11, 13, 15, 35, 55. Here 50 is also there. Now, 12 values are there. Now the next step is we need to perform the grouping or binning or bucketing. For that, let's take over here, let us take a bin with 4 items. 1, 2, and 3. 3 bins will be there. So these are the bins. Like this. So if we will talk about mean, binning by mean, for mean what we have, we need to take mean for it. That is 5 plus 10 plus 11 plus 13 divided by 4. That will give you 39 by 4, which is approximately equivalent to 10. In the same way, if we will talk about this, 15 plus 35 plus 50 plus 55 divided by 4, it will be equivalent to 38.7, which is equivalent to 39. In the same way, for the last one, it is equivalent to 146. So what we are going to do? We are going to replace all these 3 values with their respective mean values. So the first one will become 10, 10, 10 and 10. This is 39, 39, 39 and 39. And here it is 146, 146, 146 and 146. Like this. If we will talk about median, for median purpose, you can see that here we have total number of terms in a particular bin as 4, means the value is even. So for even we have n by 2. So obviously the second term we will replace it by second term. So it will be 10 for the first bin, 35, 35, 35, 35 for the second bin, and for the third one it is 92. Like this. So this is binning by median. Next one is binning by boundaries. For boundaries, as you already know, let's check whether 10 is more closer to 5 or it is more closer to 13. It is more closer to 5 or it is more closer to 13. So let us replace it by 5. 11 is closer to 5 or 13. It will be replaced by 13. So both the values will be replaced by 13. Here both the values will be replaced by 35 and 55. And both the values will be replaced by 72 and 204. So the final values for boundaries will be somewhat like this. I hope you all have, now you have an proper idea about how we need to perform this. Let us take one more final example to get some more clarity about it. So here you can see 30, in the same way we are going to take 4 bins, but first of all we need to sort it. So after sorting it will become 9, 15, 21, 4, 8, 21, then 25, 26, 34, 4, 8, 9, 15, 21, 25, 26. So here 25, one more 25 will be there. Then 26, then 28, 34, and 29. So the final sorted sequence will be somewhat like this. This is the first bin. This is the second bin. And this one is the third bin. So if we will perform smoothing with mean, you will do 4 plus 8 plus 9 plus 15 divided by 4. Here 21 plus 21 plus 25 plus 25 divided by 4. And 26 plus 28 plus 29 plus 34 divided by 4. So we need to perform it like this. Whatever value you have over here, for example, it is 10, 20, 30 and 36 by 4. It will give you value as 9. Here it will be 23. It is somewhat like this. So it will give you an approximate value over here. So after sorting and performing the mean, next thing is median. In median, you will perform n by 2 because the number of items in a bin is even. If it will be odd, then you will take n plus 1 by 2, but here it is even, so we will take n by 2. For boundaries, again, you will check the same thing. So like this, whenever we want to remove the errors or noise out of that particular data item, what we need to do? First of all, we need to perform the sorting. Second one is you need to check how many items are there and how we can equally divide those items into whatsoever number of bins. Maybe with 3 items we can divide it into 4, or with 4 items we can divide it into 3. Next value is we can perform smoothing by 3 methods. First one is by mean, in which we need to take the mean of all the terms. We will add on it and divide it by the total number. It will give you value of mean, and you will replace all the terms of that bin with that mean value. Second one is median, in which you will take the median. For odd values, it will be n plus 1 by 2. For number of even terms, it will be n by 2. So like this, you will check which particular value we can use to replace the other items. And finally, in third one, the smoothing by boundaries, we will check that particular item is closer to which particular boundary value, the left side or the right side. So like this, we can say that we can perform this binning with all these three methods. So that's all for now. Thank you.